Righto, so welcome to the fourth video, and we're going to look here at, to start with, solving matrix equations. I quite like these. They're sort of an interesting and different type of equation to solve, and so let's have a look at them. Now, I'm just going to go through on the right hand side here, just what we've got here on the left, so we'll just work it through. Now, what we have are two matrices A and B given, and we have this product A times C, okay, both representing matrices. The matrix A times the matrix C equals B. Now we're given A and B and we need to solve for C. Now normally when we're working through equations, we would think, we need to divide both sides by A in order to find C, okay? But it doesn't work that way with matrices because we can't really divide, and this is where our inverse comes into play. Alright, so what we need to do, what we do is we work through the as an algorithm first. And what I mean by that is we just work through the letters A, C and B, not even thinking about the matrices as yet. Okay, so we've got to think to ourselves, I need to eliminate this A from the left hand side. Now how do I do that? What I need to do is I need to, rather than dividing both sides by A, if I was to multiply A by its inverse, now remember we would obtain the identity matrix. Okay, because then we'd have the identity matrix there in place of A multiplying by C, and you remember any matrix multiplied by the identity matrix is the matrix itself. So if we then go A, the inverse of A times C on the left hand side, so what we're doing is on the left hand side then we are multiplying the A by its inverse. Now the order is really important. Okay, we can't change the order of the A and the C here. They have to stay where they are. So I have to put this inverse matrix of A to the left of A. If I'm to do that here on the left hand side of this equation, I have to do exactly the same thing on this right hand side. So what I'm going to do then is multiply B also by the inverse matrix of A. Okay? And then by looking at this we think, we have the inverse of A multiplied by A. That is our identity matrix. And that's then being multiplied by C, which is then equal to the inverse of A times B. And we know that the identity matrix times C is C itself. So C we can find by simply multiplying B by the inverse matrix of A. Okay, so that's what we mean when I've worked through this here. Okay, so the order is really important. You've got to keep this. Whatever order you use on the left hand side, you have to do the same order on the right hand side. Okay, so we then need to work out our inverse matrix A. Okay, the inverse of A is going to be 1 over the determinant of A times, now A is here, so we reverse the positions of 2 and 6, so we can have 6 first, 2 last, and then reverse the signs of 3 and 1, so that becomes negative 3 there and positive 1. Okay, the determinant of A, remember, is AD minus BC, so A times D, so that's 2 times 6, which is 12, minus 3 times negative 1, which is negative 3, so we end up with 12 plus 3 is 15. So our inverse is going to be 1 over 15 times 6, negative 3, 1 and 2. So we have our new matrix 6 over 15 which would be the same as common factor of 3, so that's 2 over 5. And then negative 3 over 15, that's negative 1 over 5, and then 1 over 15, and 2 over 15. So that is our inverse matrix of A. To find C then, okay, we'll just scroll this up. C therefore will be the matrix resulting from multiplying 2 over 5, negative 1 over 5, 1 over 15, 2 over 15, multiplying that matrix by B, which is 0, negative 5, 4, 1. Okay, and we can multiply these. We can do that on our calculator. Actually, I might just pause here on this screen and snap over to our CAS calculator screen. Okay, so I've got our CAS calculator up here. If we, on the main screen we're at, okay, the main, we click on keyboard, we need to go to Math 2, and you'll see here a bunch of matrices. This one's a nice handy one, that's just a 2 by 2 matrix. So we could put in here 2 fifths, go to the next one here, negative 1 fifth, 1 over 15, and then 2 over 15. So that's the first matrix. Okay, so remember we've got to keep the order the same. Next one is 0, negative 5, 4, and 1. So we can just go ahead and execute. Whoops, I've got it in decimal, so change that to standard. Go back up here and press exe again, and we've got some exact values, so we can work that through and put this result in. And there we have it. Dodgy sort of brackets there, but this is our result, which coincides with what we have here on the left. So we can work it through individually, but look, let's save time. Okay, show you working what you need to do, but when it comes to doing the multiplying, by all means use your calculator. It's just going to save you so much time. Alright, so there's our result for C. I'll just close or minimize that, and let's have a look at the next one. Okay, this time here we're going to solve for the matrix D. Okay, so we've got D equal, oops, daisy. Let's try again. Alright, we've got D A minus B equals C. And we need to solve for D, so what are we going to do? Now what we can do, although we can't divide both sides by A and that sort of thing, we can eliminate our matrix B in the same way we normally would with equations. We can add B to both sides. So our equation here can change to DA equals C plus B. Remember, it is commutative matrix addition. Alright, so we can do that. Now, in order to solve for D, we need to eliminate the A. So remember, the order is important. So this time we're going to go DA times A inverse of A, and then we've got here in brackets C plus B, and times that by the inverse of A. It is distributive, remember, so we could go C times inverse of A plus B times the inverse of A, but it's going to be simpler if we just add them first and then multiply by the inverse of A. So then we've got D times the identity matrix, which is D. So really it's important that you work through these just as an algorithm first, so that you know what you need to do in terms of your multiplication and addition. Okay, so that you solve for D algorithmically first, and then work through the matrix operations. And so you can see what's over here. We've got our matrix C plus our matrix B, and that gives this result here, 7, 0, 1, 24, just by adding the corresponding elements and that being multiplied by the inverse of A. So you'll notice here that the inverse of A is represented here with A, but with the negative one. You can do that as well in terms of noting that on there. And our determinant, so that's the inverse is given by 1 over the determinant of A times our matrix with our changes, okay, 7 up here and 1 down there, and then these reversed signs, okay, and then we multiply those results together to get here. I will show you. Okay, let's just bring this back up again, and we can do our inverse on here nice and simply. So what is our, let's get our matrix up, this one here, so it's 1 1, negative 5 and 7. Now if I put here as a power negative 1, that will actually give me our inverse. Okay, you'll notice here 7 twelfths, negative 1 twelfth, 5 twelfths and 1 twelfth. Okay, so listen, make sure, put in your working. Okay, show what you're doing, but use your calculator. It will save you some time. Okay. Okay, so let's have a look. Just note here. Okay, you'll need to work through the equations in questions 5 and 6 of the problems at the end of this booklet using this approach. But even though your calculator can perform division of matrices, you need to work through using this method. Okay. Now, one more thing to note here in this video is something called singularity. Okay, memorize this. Okay, if a matrix has an inverse, it is said to be non-singular. Okay, so it seems like a contradiction in just the way it's worded, but a non-singular matrix has an inverse. Okay, how do we determine that? Well, a matrix will not have an inverse if its determinant is 0. Simply because, well, if we have a look here at this part, our determinant is in the denominator here. So if the determinant is 0, then we can't divide by 0. Alright, we get it's undefined. Okay, so in that situation, if the determinant is 0, then our matrix will not have an inverse. And so that's what determines if a matrix is singular or not. So, take note, a singular matrix has a determinant of 0. A non-singular matrix will not. Okay? Because when determinant is not 0, then you will be able to have an inverse. And so it's non-singular. Okay, so just read that carefully again and again, and just have that carefully in your mind. A singular matrix has a determinant of 0 and therefore will not have an inverse. Okay, and question 2 sort of has a look, asks that question. Okay, just scrolling through that. Okay, note here, find the determinant of the matrix here and state whether the matrix is non-singular or not, singular or non-singular. And if it is non-singular, then find the inverse. Okay, so you just need to find the determinant. If the determinant is 0, then it's singular and won't have an inverse.